Hello everyone. Welcome back. In the previous session, we have talked about what is data, and different types of data formats, like structured, unstructured, and semi-structured. In this session, we'll talk briefly about database, and some of the most widely used databases, like relational or SQL, NoSQL, column-oriented, in-memory, and graph database. So let's get started. Take a simple example of online banking. If you make a transaction, you will see that your account balance is updated after the transaction. Or think of e-commerce, email, social media, everywhere you will find that all related information or records are stored, updated, and retrieved in every occasion. It means that, for every app or system, be it online or offline, there is a continuous flow of data. And there is a need to efficiently collect, store, update, and maintain the data flow throughout the system. Here comes the concept of database and database management system, called DBMS. So, what is a database? A database is a collection of related data with a purpose of use. The simplest examples are a telephone directory, railway timetable, or say, the contact list in your smartphone. Here, we'll talk about digital databases, located in a PC, or in a cloud server, or in a network. Once you have a database, you need a software to handle and maintain a database. This software is known as Database Management System, or DBMS. DBMS is responsible to manage the following: store and retrieve data efficiently. Concurrency, that is, managing multiple users accessing the database at the same time. Access control, for example, you cannot access your colleagues' pay slips. Central administration, that is, updating records without conflicts. Managing security. And managing crash recovery. Now, there are 4 categories of database professionals. First, the scientists, who build DBMS software in, say, IBM, Oracle, Microsoft. Secondly, the end users, typically business people, or academicians, or general users. Next comes the application programmers, who develop database packages for end users. And, finally, database administrators, who design and maintain complex enterprise-wide databases. The data analysts and data scientists mostly fit as the end users. Data engineers may be end users, developers, or administrators, depending on scenarios. Now let's talk about the types of databases. There are several types of databases. Relational or SQL, NoSQL, column-oriented, in-memory, and graph database. We'll start with relational database, which is the most traditional and widely used database. Examples of relational databases include Microsoft SQL Server, Oracle Database, MySQL, IBM DB2, PostgreSQL, MS Access, and SQLite. Relational databases are designed to handle structured data. And, we already know that, structured data is stored in a rectangle table, with predefined columns or fields, called schema. Each row in the table has a unique ID called key. With a common key, one table can quickly be related, or linked with another table. That's why these are known as relational database, which stores several related data tables. Do you recall that, whenever you want to raise a complaint for your new purchase, the call center executive might ask your customer ID or phone number? Using that as a key, they may link other data tables and gather all information related to your purchase, just to help you out. So, structured data is stored in relational databases, which is managed by Relational Database Management System, called RDBMS. A user interacts with the database through a query language, called Structured Query Language, or SQL. SQL is the industry standard for RDBMS. Several vendors have designed and developed SQL products, like SQL, Oracle SQL. Relational algebra and relational calculus are used to build the foundation of SQL. Relational database is also called as SQL database. Traditionally, the relational database has been designed to store the data in a row-wise manner. That means, data is divided into several parts, and each part is stored in a specific block within the hard disk. Now for a row-wise design, the arrangement looks like this. This is the most traditional type of data arrangement. Here, all the records for a row are stored together, and searching for a single row is much faster. This kind of row-wise database is best suited for transaction systems, like OLTP, where the user may be interested in a single row with most of the columns. They are optimized for reading and writing rows efficiently. Relational database, or SQL database, was originally designed during the 1970s, when storing data was very expensive. That's why a data model was carefully designed, with a predefined schema. Also, the data was stored into multiple relational data tables, with relational keys, to reduce data duplication and redundancy. However, recently data storage and handling cost drastically came down. At the same time, we have massive unstructured data, flowing on a real-time basis. Hence, the relational database proved to be ineffective in several cases. Subsequently, we needed to look for non-traditional ways to store and manage modern data, with all its variety, speed, and volume. This is also called big data. And to handle big data, we needed a non-tabular, flexible, non-relational database. Hence came NoSQL, that means, not only SQL. Here, depending on the requirement, the database and DBMS has both SQL and NoSQL functionalities. NoSQL databases are non-relational, non-tabular databases that support unstructured and semi-structured data beyond structured data. Further, they do not require a predefined data schema, and hence provide more flexibility. The journey towards NoSQL started probably with Google, with their Big Table. Big Table is used in Gmail, Google Maps, and website ranking. With a similar concept, there came Apache HBase. Then, Amazon came up with DynamoDB. Next, we have Cassandra, developed by Facebook. Other examples are MongoDB and Neo4j. Usually, NoSQL databases are a collection of diverse technologies, and are of several types, like key-value-based, column-oriented, document-based, and graph-based. Let's talk about the key-value database. To put it simple, here data is stored in the form of a key, and an associated value against it. A key is a unique identifier. As an example, consider a simple dataset. If we store that in a key-value database, this will look like as shown here. Amazon DynamoDB is a key-value database. What is document-based database? The document-based database is similar to key-value databases. Just the fact is, here value is a structured or semi-structured records, called document. Documents are usually stored in JSON or XML formats. A document is equivalent to a row in a relational database. Each document has a unique ID, which is a key. As an example, let's consider the previous dataset again. Storing the data in a document database will look like this. Examples of document database are CouchDB and MongoDB. Document databases are used widely in e-commerce, web analytics, blogs, and content management. We'll now talk about the column-oriented database. We have already seen that a row-oriented database stores data by rows in the hard disk. Similarly, a column-oriented database stores data by column. Here, each column is stored together in a disk block. Considering the same example, here, all records are stored by column, in the same sequence of their row ID. With this type of arrangement, column-oriented databases are optimized for reading and computing on columns efficiently. Say, if we want to search for the maximum amount from this dataset, it is computationally less expensive, as we have stored all the values of a column together. Hence, column-oriented databases are more suited for OLAP systems, where a user wants to create a summary report based on several transaction records. Also, as similar types of data are stored together, better compression can be achieved. However, adding a new row is quite expensive in column-oriented databases. Examples of column-oriented databases include Apache Cassandra and Apache HBase. Let's now talk about the graph database. In the graph database, data is stored as a connected graph with node and arc. A node represents an entity, while an arc represents the relationship. Hence, the graph database is very useful to map connected data where we need to analyze complex relationships like a social media connection or network graphs. There are several advantages of a graph database compared to a relational database. A relational database is very slow when it comes to search for information, joining multiple tables with keys. Also, a predefined schema makes any modification difficult during development. A graph database, on the other hand, is flexible and works without any predefined schema. Hence, it allows the user to store different kinds of objects and relationships in the form of a graph. A graph database also helps with quick search, as all information is connected together. Also, it is easy to visualize the relationship in a graph. Some examples where we see effective use of graph database are social network, product recommendation, network management, fraud detection, and recently contact tracing for COVID-19 patients. Neo4j is a very popular graph database. To query a Neo4j, we use Cipher Query Language or CQL. Now, we will talk about the in-memory database. To understand the in-memory database, let's understand the basics of a computer system. A processor, memory or RAM, and hard drive are the basic components of a computer system. Now look at the speed at which they operate. An HDD, being a mechanical system, cannot match up the speed of a CPU. Hence the CPU has to wait long for data feeds. Now, if you add a RAM, then the whole system can work much faster. A RAM is roughly 5,000 times faster than a traditional spinning disk. Hence, the CPU doesn't need to wait long for the data feed. Adding cache memory will further boost up performance, as it is 10 to 100 times faster than a DRAM. Now, the traditional database management system stores data in the disk. The performance is often not great due to high seek time, that is, the time it takes for the CPU to locate a particular piece of information on a storage device. On the other hand, for an in-memory database, the database management systems store data in memory. And that's why the in-memory database works more efficiently, as there is no seek time. Further, with a network of virtual computers, or with cloud, an in-memory database can extend the RAM capacity by connecting several RAM together online. This can make the in-memory database even more scalable. However, RAM is volatile. Hence, there is a risk of data loss if the power goes off. So, an HDD is also there in the system for periodic backups. SAP HANA is an in-memory database with both column and row-wise data processing capabilities. As the in-memory database is extremely fast, we can use these to handle real-time streaming data in finance, geographic information system, sentiment analysis, sensor, and image processing. So to summarize, hope you have got a basic idea about the database, and the major database types like relational or SQL, NoSQL, column-oriented, row-oriented, key-value-based, document-based, graph, and in-memory database. In the next session, we'll talk about data warehousing and business intelligence. Thank you, and I will speak to you soon.